Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video where I review percentages. Now, when it comes to percentages, there's essentially two types of questions that you would have done in the past. One where you find one quantity as a percent of another. For example, if I said you got 30 out of 50 in a test and you wanted to make that into a percent, that's the first type of question. The second type of question is finding a percent of a quantity where you already know the percent. Like if I say find 30% of 50, okay? So we're not gonna do any of the first types. We're only gonna look at finding a percent of a quantity and then using that to calculate percentage increase and decrease. So when you're finding a percent of a quantity, there's two steps. So the first thing you do, because you already know the percent, you convert the percent to a fraction or a decimal. Either one doesn't matter. Now, the way you convert a percent to a fraction or a decimal is you divide that by 100. So when you've converted the percent to a fraction or a decimal, you take that fraction or decimal and you multiply it by the quantity. Now, all of this you'll be able to do using calculators. So let's look at an example. So let's say that I wanted to find 12.5% of $128. So that's very easy. I'm just going to follow the two steps in black. Firstly, I'm going to convert the percent to a fraction. I could have chosen a decimal, but I'm going to use a fraction, and I do that by dividing by 100. So 12.5 over 100 is the same as 12.5 divided by 100. So then the second step is I take that same fraction and I times by the quantity. In this case, the quantity is a quantity of money, $128, and I'm just left with $16. All right, how easy is that? Now we're going to look at using this to calculate percentage increase and decrease. So the first thing we're going to do is we're going to increase $90 by 30%. So it may not look like it, but this is a question where we have to find a percent of a quantity. So hopefully you realize that if I want to increase something by 30%, I want to take the whole amount, which is 100% of $90, and I want to add 30% to it. What I'm actually saying is if you increase a number by 30%, that is the same as finding 130% of the original number. It's exactly the same thing. So to find 130% of 90, we're not going to do that any different to the question that we just did. So we're going to follow the two steps. Firstly, convert the percentage to a fraction or a decimal. So again, I'm going to go with a fraction and then times it by the quantity. So you can use your calculator for this and you should get $117, okay? What about if I wanted to do the opposite and decrease $90 by 30%? So if I want to decrease $90 by 30%, this is like, your favorite shirt normally costs $90 and it's been discounted by 30%. So hopefully you realize that if you discount something or reduce it by 30%, you're only paying 70% of the original price. So we want to find 70% of 90 because this time we're taking the whole amount, 100% of it, and we're subtracting 30% of it. We're taking it away. So 100 minus 30 is obviously 70. So now we're going to find 70% of 90 exactly the same way we've done in previous questions. First step, convert 70% to a fraction or a decimal. This time I'll convert to a decimal. So 70 divided by 100 is 0.7. Then I take that decimal and times by the quantity. So 0.7 times 90 gives me $63. How easy is that? Now I just want to show you examples, a few quick examples where we're going in the opposite direction. So let's look at this question here. An item was decreased by 25%, now costs $99. How much did it originally cost? So I said that this was going in the opposite direction because we're not just finding 25% of 99. What we're saying is we started with a number, decreased it by 25%, and somehow got $99, and we want to find what number we started with. So that's why we're going in the opposite direction. Now to find 25% of 99, I just times 25% by 99. Because we're going the opposite direction, we divide. So I'll show you why we divide. So let's say that the original price, so I'm going to call the original price here OP, let that be X. So what happened, we took X, we decreased it by 25%, so we took away 25% of X, and we ended up with 99. So you know from what I was just saying, by the logic I used on the previous slides, if you take an item, a number, and you decrease it by 25%, that's the same as finding 75% of the number. So 75% of the original price here is 99. So we need to find what number, when you take 75% of it, gives you 99. Of course, 75% of X just is 0.75 times X. So here, if I want to get X by itself, I want to undo timesing by 0.75, so I divide by 0.75. That's why I divide here. So I go 99 divided by 0.75. So you take the amount, divide by the percent. So if I put that on my calculator, I should get $132. So if you take 132 and decrease it by 25%, you get 99. Let's look at an example, another example, but I'm going to do this quicker. So let's look at this question here. I make bottles of cologne. I take the cost price, mark them up by 30% to make a profit. And if I sell each for $286, how much would it cost to make them? So hopefully you can cut through all the words and realize this is just saying what number, when you mark up or increase by 30%, gives you 286. So remember, when we're increasing a number by 30%, we multiply by 130 over 100 or 1.3. Increasing by 30% is the same as finding 130% of the number. So I took a number, I found 130% of it, and I got 286. So to do the opposite, all I'm going to do is divide 286 by 130%. And if you put that on your calculator, you get $220. Because if you increase 220 by 30%, you get 286. How easy is that? So when you don't know the original number, you always divide. When you do know the original number and you want to find a percent of a quantity, you multiply. All right, hope you've enjoyed this video. This has been the luckiest maths teacher in the world. Have a wonderful day.